Now let's find the approximate values of a constant function, and we'll use basically this rule that delta y is approximately equal to dy. This is how we'll find the approximation. Now we have to use differential to approximate the value of under the fourth root of 17. So we'll let y be equal to f of x, which is equal to under root, sorry, not the under root, but the fourth root of x, and x is equal to 16. We'll let x be equal to 16. So, and we'll let delta x or dx, as since they're equal, be equal to 1. So basically this is 16 plus 1, which is why we're doing this. We basically need f of x plus delta x. This is why we're doing this. We need one separate value for x and one separate value for delta x, and we've done that. So since we've let x be equal to 16, dy is equal to f prime of x into dx, and since f of x was equal to the fourth root of x, once you apply the power rule on this, you get 1 by 4 the power of x in the coefficient, and we'll subtract 1 from the actual power. So we'll do 1 over 4 minus 1, and so you get x raised to the power minus 3 by 4 dx. Now we'll take this x raised to the power minus 3 by 4 to the denominator, where it becomes x raised to the power 3 by 4, positive 3 by 4. And so you get this expression, dy is equal to dx over 4x raised to the power 3 by 4. Now, we'll replace this x with 16 because, as you remember, we let x be equal to 16. And so, once you calculate it, you find out that the value of dy is equal to 0.03125. Now, f of x is equal to the fourth root of x. We established that in the beginning. And if you take f of 16, you get the fourth root of 16. Now, since the value of x was 16, so that's why we've written 16 over here. You can replace this 16 with 2 raised to the power 4 raised to the power 1 by 4, because you can write 16 down as 2 raised to the power 4, and this 1 by 4 comes from the fourth root. Now, you can cancel out basically this 4 and this 4, and so you get 2. Now, using this, as I mentioned in the beginning, we'll use this simple notation that f of x plus delta x is approximately equal, which is why this question is about approximate values. So f of x plus delta x is approximately equal to f of x plus dy. We found dy to be equal to 2, and we found f of x to be equal to 2, and we found dy to be equal to 0.03125. Now, f of 16 plus 1 is approximately equal to f of 16 plus dy. Now, f of 17 is equal to 2 plus 0.03125, and as you know that f of x is equal to the fourth root of x, and hence this is why we have 17. The fourth root of 17 over here is approximately equal to 2.03125, and that is actually very true. And so you've actually proven the approximate value of the fourth root of 17 with this particular rule using differentials.